Welcome, students, to the final lab of the semester for NREM 301L. Let's start on our weekly lab page like usual. If we scroll down to week 17, we'll see that our topic this week is global change. And as before, we've got resources, activities, and homework. Let's start with the lab activities document, which we've already pulled up here. What we want to do in this lab is to learn about the sources of data on greenhouse gas emissions that are the driver of global warming and climate change. We'll also develop some skills to relate, summarize, and visualize data from these large data sets. We'll then apply those skills to show some trends in greenhouse gas emissions over time globally, by geographic region, and by the major economic sectors that produce these emissions. And in doing so, we'll reflect on these trends and their importance for prioritizing and taking action to reduce them. We've got some resources and activities, but the rest of these videos will go into that. So let's move there now. So let's look at our first resource here, or source of data, which is the U.S. Environmental Protection Agency. The EPA maintains information on greenhouse gas emissions and removals, partly because they have been mandated with regulating carbon dioxide and other greenhouse gases as air pollutants because they contribute to climate change. They have a lot of nice background information here, as well as current data on trends in greenhouse gas emissions. So let's look at this here. What we can see on this subpage on emissions and removals data is they have summarized some really good information that we'll be duplicating with a different source of data. One thing we can see is how much different greenhouse gases are contributing to the overall effect on climate change. Major gases like carbon dioxide, methane, and nitrous oxides are all represented here. Note that these gases represented in this graph and the data that is behind it is often standardized based on the global warming potential of carbon dioxide. That's because the absolute amounts of these various gases can differ quite a bit. But the global warming potential is what's really important for us to represent. So methane, while it is actually a much smaller concentration in the atmosphere, has a much greater warming potential than carbon dioxide. So while it's not 16% of the total greenhouse gases in the atmosphere, its warming effect is equal to 16% of the total. If we scroll down, we can see another summary, which is the greenhouse gas emissions by economic sector. Here we can see in the U.S. at least, agriculture, forestry, and other land uses, things that we talk about and teach you about here in the NREM department, is about 1/4 of the total, similar to electricity and heat production. Given the source of data, these categories of sector are not always broken out the same, so you have to understand what actual activities are categorized in from each data source. So we don't have to go any further here. Let's look at our next source of data. Let's move to the United Nations Food and Agriculture Organization and the data that they have. Their data on not just food and agriculture, but also climate change and greenhouse gas emissions is included in their FAOSTAT website. It's a big website with a lot of data, so it might take a few seconds to bring up. Here you can see various kinds of summaries and visualizations, as we did in EPA. And what's nice here is they've also linked this data to the 17 Sustainable Development Goals as developed by the United Nations. The data help to provide indicators of how we're doing as we progress toward these goals. In our case, though, we want to actually explore the data itself. So click on that link. As mentioned, there's lots of food agriculture data, including trade and prices, but we want to be looking at the climate change data. Here, we want to look at emissions. And while FAO breaks down emissions by major agricultural activities, we want to look at emissions totals. So we're not taken directly to the data, but actually now we're brought up additional filters that we can use to select the kind of data we're interested in. That's by geographic country or region, the type of greenhouse gas emissions we're interested in, the particular sources or sectors that are responsible for those emissions, and the years of interest. In our case, we'll want to choose all countries and regions. We can choose CO2 equivalents using the AR5 method, and that would be for all types of greenhouse gases. We'll want to choose all of the sources and sectors because that includes not just agriculture, but in our case, or in FAO's case, energy, industrial processes, waste, and other sources. And finally, we'll want to choose all of the years. Now that's a lot of data to look at. So while you can show the data on this web page, it's easier if you download the data and then bring it up in a spreadsheet. Now, what form does the data come in? Well, the file type would be either what's called a comma-separated value, or CSV file, or directly as a Microsoft Excel format. In our case, we chose a CSV because that made it easier to bring it up in a Google Sheet. So while we're not going to do that in the video, you can see the Google Sheet in the next video that shows what that data looks like. Now that we have looked at some of the sources of greenhouse gas emissions data, let's look at the worksheet we created based on that FAOSTAT data we downloaded. Like other worksheets in this class, we've added some additional tabs here to help with the work you'll be doing. There are some instructions which we won't go over in detail here because we'll be actually going through how to perform these tasks in other videos. We have a tab here called metadata, and this is important for big data sets with lots of columns or fields so that the user understands what those names refer to. In our case, we have a column for worksheet, meaning the worksheet tab that these column headers refer to. And for example, in the regions worksheet, the first column is going to be called country or area. This seems relatively straightforward, but some things such as intermediate region code or other types of things might not seem exactly familiar to us, and so a metadata sheet, or whether it's a standalone document, should have a description of those column headers so the user has a basic understanding of what they refer to. So in this case, intermediate region code is a simple, unique numeric code that stands for the name of an intermediate region. That way, if this name changes over time, we know with the code exactly what that refers to. Okay, we won't go into much detail here, but if you are having issues with understanding what you're looking at in the other worksheet tabs, this metadata sheet might help. The Regions tab has basic information about the places where greenhouse gas emissions data has been collected. Obviously the country or area, but also the name of the geographic region that country is categorized in. There are some sub-region names for those who want to split that up a little bit further, but we're just going to work with the primary geographic region. A couple other things to note here are there some indications of whether a country fits in one of these particular categories, such as a least developed country, a landlocked country, or a small island developing state. So for example, Afghanistan, the first country on our list, is considered by the United Nations both least developed and landlocked, meaning that it does not have access to a seaport. American Samoa, which is not a country by the way, but a territory of the United States, is also listed under the country or area region because it is distinct from most of the other states and territories in the U.S. It is not landlocked, but of course the opposite, a small island developing state. It's not considered least developed, but it does have this special designation. So these are also sometimes important because you might be interested in a particular type of country or region and their greenhouse gas emissions. So these indications here can be helpful for certain kinds of investigations. Let's move on to the emissions tab. This is what we're really going to be working with. The data we downloaded included the country. The element that we're going to be measuring, if you remember, was the CO2 equivalents of greenhouse gas emissions based on the AR5 method. We wanted all the various economic sectors, which are called items here in the column header. In this case, the years 1990 to 2019 were downloaded. The units that the data are listed in are called kilotons, or 1,000 metric tons. So, for example, CO2 equivalents of 210 in this case means 210 kilotons for that sector, for that country, for that year. The flag and flag description is how that data was collected. We won't go into that, but if you're interested, you can look into that a little bit more. Finally, we have some questions. And so I suggest you look over these questions and think about them before you start working with the data. That will help you when you come back and need to respond to them. Okay, those are all the worksheet tabs. The next video is going to help you learn how to use some of the functions that you'll need to apply to this data to come up with the summaries and visualizations. Good luck.